All right, so it's now the last meeting for the Data Science at Georgia Tech Club for the Kaggle-CLEF Fall 2023 group. And we've just finished up our internal competition. So a couple months ago, I put together a community-run Kaggle competition, and we all voted on a particular competition that we'd like to try out. So we voted across 4 different combinations of things. There was a really basic regression problem, a really basic classification problem. There was like an NLP type problem and a vision problem. And we all decided that we wanted to do something with vision. So this fall, we did a dog breed identification Kaggle competition. So the purpose of this competition is to be able to identify specific breeds of dogs. So there is this very standard image data set called ImageNet. And for this competition, they pulled out the dog-specific images from this data set. So there are approximately 120 different species of dogs, and each of those has, on the order of 100 or so images. And you'll get images of dogs that look something to the right. So we ran this for 2 months. Some of the constraints that I had set on the competition were, you're a member of the club, and you do this in groups of 2 to 3. So we had participation from a couple of groups, and here are the winners. So for the leaderboard competition, first place goes to Elmo, Jennifer, and Ben. We had a close second place going to Shashank and Xiaomeng. For our working notes competition, which is the other part of the competition that was weighted pretty much equally to the leaderboard competition, we had first place by Shashank and Xiaomeng, where they wrote a pretty good working notes. So congratulations to all the winners. I'm glad to see that there is a good participation in the competition. Everyone who participated and won will get a $50 gift card of their choice. So I think everyone who was interested has filled out the form, and I'll get those out to you all after this meeting. With that, I'd like to have some of the people who competed to share their experiences. So it sounds like we can start with Elmo.
Do I show the notebook?
Yeah.
Or do I just like
roughly 5 minutes or so.
Okay, so I didn't really know much when I started. I just tried a bunch of stuff over the course of this competition. So like I tried ResNet, I tried Vision Transformer, and then I tried like Inception V3, and then I tried like EfficientNet, and then I just found that EfficientNet just works the best for the smallest data set. And then I also like tried a lot of data augmentation, and yeah, I think I got my inspiration from Jennifer, because like I didn't do the rotation to 180, and I think the model generalized better when I did like the augmentation to like 180, like, and then for the brightness stuff I didn't really configure that much. I just used like the standard one. And then for my optimizer and my scheduler, I used just basic SGD, and my scheduler was a step LR. I found that, I don't know, I can't optimize Atom. For some reason, Atom just doesn't work properly for me, and it's like overfit. And then I think SGD like generalized better for me. And then for my final solution, I just basically use EfficientNet V2. It comes with like a lot of good features like stochastic depth, like when you like basically just cut out like part of your model, like like the depth, and then you can just like pretty much just and it's basically improve regularization, and that really worked well for me. At first, I didn't really use the Kaggle notebook, and then I realized you can use it, and then I basically just moved to larger models after that, because the 2T4 is really large. So yeah, let me think. I think that was like basically my solution, pretty much. And okay, and then the parameters, I guess. I use like really aggressive parameters. I use like 6 training epoch for like the transfer learning, but then like I just like I think my gamma for my step OR was like 0.2 or something, but I found that gave me really good regularization. So I got like my training loss was like 0.4 when I did it in the notebook, but when I submit it was like 0.24. So like yeah, the generalization was pretty good. I think it's because the data augmentation makes like the test loss much higher than the training loss much higher than the test loss. Yeah, that was basically my solution.
Cool. A question from my end. Do you have a rough sense of what your scores were over time? I think the final score was 0.24. But do
Yes.
you know like how much things like data augmentation contributed to that final solution?
Oh, I started things as I go. I think I started with ResNet with no augmentation. I got like 0.8987, and then augmentation brought it to like 0.6, and then I changed models. And then yeah, and then I changed model. I got it to like 0.5 and 0.54 and 0.53, and then I can't really go further because like overfitting and stuff. And then I changed to EfficientNet, and I got to like 0.37, and that also included like the more augmentation of the rotation. I think the rotation was really important, that it generalized the feature no matter the orientation of the picture. I only put like 10 at first.
Cool. Any questions from the room?
Is efficient net also one of the vision transformers?
Hello? Can you say that again?
Yeah, is efficient net also one of the vision transformers?
No. Vision is not based on a vision transformer. It's a architecture by Google, and then it's just based on normal it's based on normal pretty much like ResNet model, but like the core concept was like you scale the picture with the depth and like the what do you call it, the dimensions, and you scale it like compoundly. So like when you move on larger model, you just increase the image size, and yeah, and then they show that it worked really well, much because vision transformer works much better with a lot of data because it parallelized pretty well. But like we have really small data, so it worked pretty bad for me, vision transformer.
Awesome. Any other questions? All right. Thanks, Elmo.
Okay.
Next is Jennifer.
Yes, I have a bit of a presentation that I put together. Nothing fancy. It just helps me talk. Um, okay, yeah. So as Elmo mentioned, we kind of did somewhat separate things, mainly because of time constraints, but ended up sort of bouncing ideas off each other towards the end. I ended up just submitting what I had and getting third place. So that's kind of why it says third place submission. So yeah, I'm just gonna like walk through the strategy a little bit of what I thought of doing and then what I ended up doing. I did initially try and train a CNN from scratch, which was hilarious. More for just like a learning opportunity, but then just quickly scrapped that and started looking into pre-trained models. I hadn't really had much experience with that until this competition, so it was a great opportunity to dive in a little bit deeper. And through that process, I found a couple tutorials on well, Kaggle as well as one from Keras that I found pretty useful, describing like what transfer learning is and what are some basic steps that you can take to start using it. I guess so everyone is on the same page, I'll describe a little bit about what transfer learning is. Apologies if this is just too basic for people, but essentially what it is you're taking layers from a previously trained model, and then you freeze those layers to like not destroy any sort of information that was previously learned from them. And then you take those those layers and you add some new trainable layers on top of them. And then these turn into features that will eventually turn into predictions for a new data set. And eventually you just train the new layers on your data set. So it's a great way of taking general features that can apply to sort of any image, and then fine tune to your smaller data set the specific things that are applicable to your new data set. So that's kind of like a brief overview of what transfer learning is. In terms of my solution, I didn't use EfficientNet. I used Inception v3, which it's a model that was developed at Google, and it's actually pre-trained on ImageNet. And the more, I guess, concrete process here, I can share my notebook after, but the first thing that you would do is you instantiate a base model, and then you load the pre-trained weights coming from ImageNet. And then you run your data set through it, and through that process, you can get features from that base model. And then you can take those features and use them as an input for a new smaller model that was literally just like a fully connected layer. And that's the thing that you train instead of training the entire model. So yeah, that's kind of the general process. And I guess in terms of the score, I was just happy with the score I got and didn't try and really improve it. Elmo tried to help me improve it a little bit, but I was like, I just can't get any good scores using EfficientNet. So it's, I think, a good thing that he tried to do it on his own. But yeah, that's basically the presentation I had. Happy to answer any questions.
What kind of compute resources did you use?
Oh, I just did it through the Kaggle notebook. I did have to use the GPU, I guess, selection when you're choosing your runtime.
What other models did you try?
There was another one called Exception that I tried as well, and that one didn't work well at all. And then EfficientNet as well, but this one was the first one that I came across, and it seemed to work well, so I didn't really go much further.
Awesome. Any other questions from the room? All right. Thank you, Jen.
Cool.
And then for the best working notes and also second place in the leaderboard, we have Shashank. So Shashank.
You can see my screen.
Yep.
Okay, so I basically started, I think, in this kind of in the same boat as the other two presenters. Wasn't very experienced with this at the beginning, so the starter notebook really helped. I think using ResNet 18 to get embeddings and use that as features was worked pretty well. So the original notebook had that and on top of that, it was using logistic regression. So I think that was able to get, I think, 0.9 on the leaderboard. And I tried using all the features, which basically means remove the PCA layer. And that was able to get to, I think, 0.7 from there. And then I tried to see if I can change the logistic regression into some sort of a neural network. So I tried that on top of the same embeddings, but I did not get any better scores. I kind of got exactly the same score. I was trying to use the validation accuracy, and it it kept hovering around 0.74, 0.75. So that did not improve it. So I decided to see if there are some other image embedding models that I can use. So ultimately, I used these two, ResNet 50 and Inception V3. So these two are both pretty huge models. Extracting embeddings and outputting them and then loading them again was um, kind of running into a little bit of a RAM issue. So I basically chained them together, as was also in some of the examples of such problems. So this basically concatenated both the embeddings and used them. So ResNet, when I used just ResNet 50, it was able to get to somewhere around, I think, 0.3. No, I think 0.35 or something. Uh, I'm not actually able to remember. Yeah, so this is validation accuracy. This is not the same as the leaderboard. So this is where it went to with just ResNet 50. When I used just Inception, it was around 0.87, I think. So combining them sounded like a good idea. So I think that's what got me here. I tried to add one more to see if this would scale, but and the one that I chose was DenseNet 161. I think this is the, even larger than the other two models, and not only did it slow down the runtime by a lot, it did not move the needle with respect to accuracy and loss. So I decided to drop it after that. And I think other than this modeling part, the pre-processing was actually one of the things that I tried, but I think there was much room for improvement here. So I ended up using some very basic pre-processing steps. What I had in mind was to do a couple more things. What I did was I tried some random flipping and random rotating of the image in the training set. Um, I wanted to do a couple more things, but I kind of didn't get the time to dig into all that. Um, One of them was to look at the validation set for different classes and see if some classes are performing a little poorly. Probably if there is some skew in terms of how much training data we have for different classes, and we could try to oversample it and apply some data augmentation so that it's not exactly the same, and see if that is able to overcome the lack of training data for that example. So I kind of just managed to run it once, and it did not work as well as I thought. But I definitely think there was room for improvement at that place. So yeah, I think that was the last thing that I was trying before I submitted. I think that's all. Any
Great.
questions?
Yeah, I have a quick question. So I noticed that you oversampled on the training data set.
Yeah.
Did you notice any significant improvement from that?
No, actually, I was pretty hopeful about that, but I actually did not get any improvement there. I think it wasn't very clean at the time I was doing it. There might have been other changes that I was trying at that time. So that was my goal, to oversample some classes or maybe oversample the entire training set data as a whole and apply the transformations to part of them and keep the other part as it is, so that we kind of have pseudo extra training data. Yeah, but yeah, I did not get improvement by that.
For sure.
When you oversampled, did you, I guess, have two similar images in the data set or like multiple similar images, or did you apply some transforming, like some
Yes. So
augmentation?
yeah. So my goal was that so every time we resample, and if it is not a new image, then we kind of apply a different transformation so that the data is not the same. I think we could simply keep resampling and randomly choosing whether or not to apply different data augmentation, and over a large enough data set we'll kind of have some repetitions, but they won't matter because on average it might like cancel the noise.
Cool. Are there any other questions from the room? Cool. Thank you, Shashank. And
Thanks.
yeah, great presentations, everyone. So with that, I'd like to congratulate the winners one more time for both the leaderboard and the working notes competition. Super excited that that we got to run it. This is my first time like organizing a Kaggle competition of any kind, so it's kind of neat to see the people participating and actually doing some really interesting things with vision models. So with that, I will end the recording.